Welcome to Team 3's presentation on autonomous vehicles. I'm Natalie Chiesa.
Daniel Farley.
Sheridan Hopkins.
Luna Sanchez.
Jordy Vargas.
We're about to introduce the technology, the competitive suppliers, and the projected cost. We will also discuss potential applications, advantages and disadvantages, the assessment of the future adoption of the vehicles, and the role of information technology overall.
In this slide, I will do an overview of how autonomous vehicles work, and there are some functions that are important that are listed here. Computer controls operation of a vehicle using software and sensors, the light detection and ranging system that detects objects range with high accuracy and precision. The ultrasonic sensors are a sound-based sensor used for parking applications. The radar, which is a radio frequency-based sensor for spatial data collection. The software incorporates GPS data, sensor data, and safety algorithms, and these cars are primarily operated by a computer where there is no human control or intervention, but requires human oversight. These functions can adapt to changing situations. The car can reroute itself and/or notice changes in the roads and highways, obey obvious signs that humans would pay attention to while they are driving as well. In the next slide, there are a few illustrations that demonstrate how the cars operate. In the first image, you can see the major sensors that play a big role in generating information, as noted in the previous slide. You can see in this image how the vehicle makes decisions and reacts upon the surrounding environment, which then leads to decoding of information and the message is sent to the controls. In the second image, you can see how these vehicles can pick up on other vehicles on the road, as well as pedestrians. In the third image, you can see how the computer vision and sensors allow these vehicles to operate on the road and uses path planning to detect where it is going so that you may reach your destination safely. In 2018, General Motors Co. and Waymo LLC were named the top-ranking autonomous car leader. The highly ranked competitors for 2019 are GM, Waymo. Uber is making a return because they're coming up with more plans to help their own company. For instance, they want to make self-driving robotic taxis by mid-2019. Uber also has created a recent deal to partner with Toyota. Volkswagen is also becoming more proactive as they are the world's second largest automaker. This diagram shows how GM and Waymo are on the leaderboard and are top in the race for autonomous vehicles. On the x-axis, Navigant Research Leaderboard measured their strategy that they were using and how effective it is for that specific company. On the y-axis, Navigant Research Leaderboard measured the execution for each company and how well each company followed through with their strategy. There are more companies creating partnerships so they can become huge automakers and be ranked as top leaders in the industry.
Projected costs. The projected cost of an AV can range as low as $70,000 to about $150,000. Over time, costs of units would decline as more are being produced. As the amount of units on the road increases, suppliers adapt and become more efficient as the technology matures. This product would be for personal use, meaning that it would cost more as compared to a traditional car, because traditional cars are not equipped with the same sensors, cameras, software, and hardware. AV for product or material transportation could potentially see cost advantages because the vehicles would not need human safety features that could be pricey. They would need to be larger in size to transport enough materials and products. Included is a photo of a poll of how much people would be willing to pay for a fully autonomous vehicle.
The technology in these vehicles allows for different business applications. The sensors, radars, and cameras, and the fact that this is still a relatively new innovation means that it will affect different businesses. Autonomous vehicles can impact industries by either allowing them to incorporate the technology or it'll affect the amount of business in that industry. In the next couple of slides, we'll be discussing these two impacts and what they look like. First, we have the incorporation of autonomous vehicles. If AVs are more common, then that means that they will not have anyone to fill them up with gas. Gas stations will have to adapt to allow these vehicles to fill up without the need of a driver, and they could incorporate employees at gas stations to fill up the cars with gas or a type of drive-through. Public transportation like Uber or taxis will be able to expand their business because they won't need drivers for these jobs. With AV, customers will be able to share transportation more efficiently. Delivery services like Amazon, UPS, or FedEx will be able to deliver shipments more efficiently because they will be able to deliver at all times without the need of a driver. National trucking services have already used autonomous vehicles to make deliveries. In this picture, we see an Uber-owned 18-wheeler that made a 132-mile delivery of a beer shipment in Colorado. Different industries will be able to take advantage of autonomous vehicles. For example, insurance. If more AVs are on the road, then it is reasonable to assume that less people are driving, which means that human-caused accidents will decrease and so will the need for insurance. However, something that the insurance companies might want to look at is providing insurance for the car manufacturers in case there are technical issues with the vehicles. It is expected that car manufacturers will try to implement AV into their line of production. We can assume this because of the ride sharing that we mentioned earlier. It is cheaper and more convenient to ride share than to own your own vehicle, so car manufacturers will want to create the best AV they can to be the best option, since AV will be the cheaper option and people won't be inclined to purchase self-driving vehicles.
Now we're going to discuss the advantages. As previously mentioned, with no driver at the wheel, there is no room for human error with autonomous vehicles. This means that there will be fewer mistakes on the road and less incidents would occur as well as because of the driver's abilities. It is a safety hazard when night drivers are feeling exhausted. With AVs, night drivers would have the option to sleep during the ride, reducing the number of accidents caused by fatigue. Furthermore, if there are fewer accidents on the road, then traffic would be reduced and not be as chaotic since traffic is usually caused by accidents. With less traffic, commute time would decrease as well. AVs are self-aware and it would diminish the amount of car theft that happens. Every piece of technology has its advantages and disadvantages. AVs are no different. There are several disadvantages that can be discussed, but these are just a few to look over. This kind of technology is very advanced, and advanced technology is typically new and expensive, making the cost of these vehicles very pricey. Technology also breaks down, so vehicle maintenance fees would be costly as well. When software controls the vehicles, that could mean two things. Hackers will find it easier to get in control of the vehicle, and terrorists may also use the technology to their advantage in order to implement bombs within the vehicle. If there is a problem with the software or there's an emergency, drivers who grew up with AVs will not be able to transport themselves since they will not have nearly as much experience driving the vehicles themselves and did not develop traditional driving skills that are required when driving a regular operated vehicle. On the topic of software being a problem, the technology may glitch and become a safety hazard for drivers and passengers because the car system would be malfunctioning and could cause an accident.
Assessment of future adoption. The United States would benefit immensely and realize about $800 billion of public benefits from automated vehicles being used by 2030. Accidents in the U.S. could be reduced by 90%, saving about $190 million in medical bills and countless lives. Time is money, and about 50 minutes a day could be used doing something else because the AV is doing the work, and more time than we would think is spent on the roads. Traffic could be reduced by 30%. Semi-autonomous vehicles would be upgraded to fully autonomous cars by adjusting or adding some pieces of hardware and software. Just take it to the shop, and a service fee, which would not be cheap, will be applied to modify the car. AV technology could also threaten some people's economic interests. Take truck drivers, for example. About 3.5 million drivers could potentially lose their jobs should an organization choose to switch to AV. New laws and contracts would need to be drafted and made for accident liability. Roads and other types of infrastructure will need to be altered to work for both traditional driver cars and AV.
Finally, the significance of the information technology aboard. First of all, intellectual property may create barriers to entry, which could ultimately lead to higher costs for the consumer. With the billions of dollars that have poured into the development of AVs, companies won't just give away that information for free. Centralized vehicle tracking systems would require standard protocols for vehicle communication and reporting, similar to air traffic control. This data would then be in the hands of the AV companies, which could lead to concerns about privacy. While autonomous vehicles may be safer than human drivers, there will be regulation of driving algorithms and thorough investigation when accidents do occur. We have seen similar instances in the regulation of air travel safety with the Boeing 747 MAX. This government oversight could delay the implementation of the technology. The need for uninterrupted and continuous use requires redundant and resilient onboard information technology. Hope you enjoyed this presentation. Here are our list of sources.